Okay, I think that our class as a whole really loves the area problems. Um, Here we have two graphs, f of x is equal to x minus 2x squared, and g of x is equal to negative 5x. And what is the area of the region enclosed by these graphs? So we do have to figure out our limits, our boundaries, and then we're going to need to take an antiderivative. This is a non-calculator problem too, so actually a pretty challenging problem. Let's sketch out a region of these two functions in their general shape. Well, we know that negative 5x is going to just be a straight line right there, so that'll be g of x. And we know that this function right here is a quadratic that is a negative on the squared part, so it's going to go down. I'm going to quickly factor out those zeros. So x 1 minus 2x. So I'm going to have a 0 at x equals 0 and a 0 at x equals 1 half. Alright, so it's going to pass through 0, it's a quadratic, and then I'm going to have this type of look to my function. Okay. We need to figure out when these two functions equal each other. We know that one of the values is going to be 0. We need to figure out this without a calculator, so we need to set these two functions equal to each other. I'm going to do a little bit of erasing. I'm going to pause and set up that. Okay, back from the pause. So I set the two functions equal to each other, f of x and g of x. And we need to find the two values that they're going to be equal to each other at. We already know that one of them is going to be 0, but I need to find the other one, this positive value right here. So I'm going to do a little bit of a rearranging algebraically. I'm going to move all my values to this side and solve it as a quadratic. Now I'm choosing to move the values to the right side because I want this 2x squared to be positive. So I'm going to have 2x squared minus x minus 5x. So then I'm going to go ahead and factor this. Let me erase that. Put these two together. So 2x squared minus 6x, and I'm going to factor out a 6, or an x, excuse me, and a 2, and I'm going to be left with x minus 3. So that value right there is 3. Okay, so I've kind of got my limits now. Now I need to set up my integral. A lot of math in this problem you're going to be able to have to do in a short period of time. Alright, I set up the integral, and again, I know I already found my starting limit of 0 right here, and my upper limit of 3 right there. I know that this is the region that I'm trying to find the area of. Now I need to figure out which function is on the top. That's this quadratic right here, so that's f of x, which is x minus 2x squared. And my squared's on the wrong part. I've got x minus 2x squared. There we go. Minus negative 5x. I'm going to look at this integrand and add like terms, subtract like terms. So I'm going to have negative 2x squared plus 6x. This becomes positive, and I add it to the x. Now this is what I'm taking the integral of, and I'm going to find my capital F to be negative 2x cubed over 3 plus 6x squared over 2, and I can go ahead and identify that that is going to be 3. Okay. Now what I need to do is plug in to the fundamental theorem, capital F of B minus capital F of A, where this is B and this is A. But because I have a polynomial term, no cosine, no e, I know that when I plug 0 into this capital F, it's going to be 0. So capital F of A is going to be 0. When I plug in 3, I need to do that evaluation out. I can't leave it because we have a multiple choice problem. So 3 cubed is 27. 27 divided by 3 is 9. 9 times negative 2 is a negative 18. That's the first part. Plus 3 cubed, or excuse me, 3 squared is 9 times 3 is 27. Add these up, we get our answer choice of 9. A lot of work to do in this problem. You can look at the timer, we're already at 6 minutes. And I paused. So a lot to do in this problem, and an exciting problem. We can see visually it's very cool. We used the fundamental theorem, we took antiderivatives. But if you were doing this problem on the AP exam, you'd want to work a lot faster than I did, and look for shortcuts and ways to speed your process up. Okay, I'll see you guys back for problem 18.